Welcome everyone to Simplilearn's YouTube channel. Java was, is and always will be the most sought programming language in the IT industry. Yes, you guessed it right. The topic for today's discussion is the Java tutorial for beginners. So this particular part will be the part 1 of the tutorial. So without further ado, let's dive into the agenda for today's discussion. So we will begin with a brief introduction to Java programming language, where we will go through a little history of Java and the inventor who invented the Java programming language and few more points. Followed by the introduction to Java, we will dive into the object-oriented concepts in Java, where we will learn encapsulation, abstraction, polymorphism, and inheritance. So once we are done with the object-oriented concepts in Java, we will enter into the most crucial concept in Java, that is the access modifiers, where we will learn how Java provides access to its objects and classes. Next after that, we will learn methods in Java. Followed by the methods, we will go through the most important part of Java, the data structures, or in other words, the Java collections. And finally, we will be winding up the session by going through the file handling techniques in Java. So I think I made myself clear with the agenda. Now let's begin with the first topic. So the first topic is the introduction to Java. So what exactly is Java is the first point of discussion in Introduction to Java. So this will be giving us the definition of Java programming language. So basically, Java is a class-based, object-oriented, high-level programming language invented by James Gosling in the year 1995. So Java programming language is used in various fields. Some of the basic examples where Java is used are the software development. Followed by that, Java is used in desktop and mobile development and also the Android OS development. So followed by the brief history of Java, its definition and its implementation, we will dive into the next subtopic of the introduction in Java, which will include the features that the Java programming language provides. So the significant features that Java programming language has to offer are: the first one, Java is an object-oriented programming language. So everything you create in Java is in the form of an object. So basically, the class is the blueprint of each and every object. So once you design the class, you can implement the class and create any number of objects you require in your programming language. So Java is an object-oriented phenomenon that makes it highly extensible. Every component programmed in Java is treated as an object. So followed by the first feature, we will learn the second feature. So the second feature has to say that Java is completely platform independent. So Java follows write once and run anywhere principle. So it uses JVM or the Java virtual machine. This makes it completely platform independent. How? Yes, I'm going to explain that concept. So what exactly happens in Java is Java has a component called Java virtual machine. So basically, whatever the program you write, that particular program will be compiled. But in Java, things are a little different. So once you write the code, the compiler will translate the code from high-level language into low-level language, which is the bytecode. So this particular bytecode will be sent to the Java virtual machine for compilation. So the Java virtual machine will compile the bytecode instead of the code itself. So this particular feature makes the Java virtual machine to perform in any device regardless of the operating system platform it is running on. So followed by the second feature, we will dive into the third feature. So the third feature says that Java is completely simple to learn. The core reason to invent Java was to make the things simple to understand, read, and write. So all the object-oriented programming concepts and high readability make Java the simplest of all. Followed by the third feature, we have the next feature, which has to say Java is highly secure. Java follows authentication based on public key encryption. So this particular methodology makes Java highly secure, and this is used to design virus-free systems. So followed by the fourth feature, we have the fifth feature. The fifth feature says that Java is architecturally neutral. Java Runtime Machine provides ability of generating architecture neutral objects that can run on multiple processors. So followed by the sixth feature, we have the seventh feature, which says Java is highly portable. Java uses a compiler written using ANSI C and POSIX substitute, making it portable and requires absolutely no dependencies to implement code in any architecture. So we have discussed about the JVM architecture earlier. So this JVM makes Java highly portable and capable to run on any operating system platform. So followed by that, we have the next feature that says Java is a completely robust programming language. Java eliminates most of the number of errors in compile time itself. This makes Java robust against any errors. So what the last feature of Java has to say about? Java has multi-threaded performance. Java is capable to execute code simultaneously above multiple processors at the same time. This is possible because of the Java's multi-threaded nature. So these were the important features of Java programming language. Followed by that, the next subsegment in the introduction to Java are the data types in Java. So the data types are the building blocks of any programming language. So Java supports the following data types in itself. So the first building block in Java, that is the data type supported by Java, is the byte. Next we have short. Followed by that we have int. Right next to it we have long. On the other hand, we have char, Boolean, double, and finally float. There are also a few more advancements in the data types in Java which are supported in the latest versions as well. So followed by the crucial data types supported in Java programming language, the next concept that we will be discussing in Introduction to Java is the operators in Java. So the Java programming language has support for various operators in real time. So some of the mainly used operators in Java are addition operator, subtraction operator, multiplication operator, division, increment, decrement, and modulus operators. So the examples for these operators are specified in the last column of this particular table. Also, we will go through a practical program for a better way of understanding operators in Java. So you can see that we have switched to the practical mode. Now we are on Eclipse IDE. Now let's quickly create a Java project. So I have specified Simplilearn Java as my project name. You can see on the left hand, we have the Simplilearn Java. Now we have the source folder. Let's create a new package. Now we have our package here. Let's create a new class. So the new class has been successfully created. So as you can see, I have a program on my screen. So this particular program is designed to perform addition, subtraction, multiplication, division, and modulus operations respectively. And finally, we have another last option to exit the program. So basically, we are going to use switch cases for this particular operation. So the first case is for addition, second for subtraction. Followed by that, we have multiplication. Next, we have division. Next is mod, and finally exit. So this is the program flow. Now let's quickly run this. As you can see, the program got successfully executed and the output console is asking for an input. Now let's enter the first number. Now let's enter the second number. So now let's choose the operation to be performed. 1 for addition, 2 for subtraction, 3 for multiplication, 4 for division, 5 for modulus, and 6 for exit. Now let's choose 1. Now we can see the result as 15. Now again the loop has started and it is asking for an input. Let's give in 15 as the first number and 5 as the second number. Now we have various options. Let's select 2 for subtraction, and there you go, we have the result. Now with that practical program executed, we will continue with our next topic. So the next topic in our docket is keywords used in Java. So before diving deep into the keywords in Java, we will understand what exactly is a keyword. So keywords are special words that has special meaning, and these particular keywords are completely predefined. That means the architects of Java programming language have previously declared keywords and defined the functionality of those particular keywords. Now, Java has the following keywords in its docket. Some of the mainly used keywords are boolean, final, switch, while, continue, if, class, new, static, default, extends, and many more. So for a quick briefing, you can take a screenshot of this particular slide. Now, followed by the keywords in Java, we should move ahead into the next topic where we will discuss about the conditional statements in Java. So what exactly are conditional statements? So conditional statements are specific statements which will be executed when the condition specified is true. Unless the condition is true, the code segment where the conditional block is placed will not be executed. So Java provides us with the following conditional statements, which are the if else, and nested if. So first we will discuss if statement. So on the right side, you can see the flow diagram. The flow diagram includes the control. The control of the program will enter the conditional statements where the condition is processed. In case if the compiler finds the condition is satisfied and the statement is true, then the control will execute the statement which is inside the conditional statement. Else, the control flow will directly consider the condition to be false and will jump into the next segment of code, and that particular statement will be executed. So now we have understood the definition of if loop. Now followed by if loop, we will continue with if else loop. So now on my screen, you can see on the right side, we have another flow diagram which is completely similar to the if loop. The only difference is we also have an else statement here. Basically, the program control will enter into the condition. So the condition will be checked. If the condition is true, then a particular code segment should be executed. If the condition is false, then another segment on the other hand will be executed. Once after either of the statements are executed, the control will enter into the next code segment of the code, and that particular next statement will be executed and the control will exit the loop. Now for a better understanding of both if and if else loops, we will execute a program. Now on my screen, you can see a code segment which is based on if and if else loops. Now here we will try to take an input. If the number is greater than 0, then the output should be number is positive. If anywhere we provide a negative symbol, then the output should be number is negative. Now let's try to execute this program. So you can see the program got successfully executed and it is asking for an input. Now let's enter a random number which is 10. So we have the output which says number is positive. Now that we have finished the execution of that particular program based on if and if else conditions, we will move ahead into the next type of conditional statement, which is nested if else loop. So followed by if else, we have the else if ladder or nested if else loop. So the control flow is completely same to that of the if else loop, but the only situation that varies here is that we have multiple else blocks. Now here you can see multiple choices. If the choice is 1, my particular food selection will be noodles. If the choice is 2, it will be milkshake, 3 for fruits, 4 for coffee. And if I provide any other number other than 1, 2, 3, and 4, the statement should be invalid input. Now let's try to execute this program. As you can see, the program got successfully executed and the console is asking me for an input. Now let's select 3 for fruits. So that's how it works. It's completely similar to switch statement. Having said that, let us also execute a program based on switch control statement. So on my screen, you can see a program based on switch control statement. So we have months of a year. So for case 1, we should be providing the output as January. Similarly, next we'll have February, March, April, and finally we have December. If the number provided is any other number other than the numbers between 1 to 12, then the switch control statement should throw an output which says invalid input. Now let's try to quickly execute this program. So there you go, we have our program executed and we have our console asking for an input. Let's provide 12. So we have December. Now our program is running successfully. Now with this we shall continue with our next topic. So the next topic in the docket is loops in Java. Earlier we discussed the control statements, which were the if else ladder, switch, etc. Now we will continue with the loops in Java, which are the for loop, while loop, and do while loop. So the first one we have is the for loop. On the right hand side, you can see a flow diagram. Now the program will start at the initialization state. Once the initialization process is finished, the control will enter into the condition. So the control will check the condition. In case if the condition is true, then the statement will be executed and the control will flow into the increment or decrement statement. And again, the control flow will enter into the condition. For a quick recap, when you look at the for loop, then we have I is equals to 0, I is less than or equal to a specific number, then I increment or decrement. So the first part where I is equals to 0 is the initialization. That's where you provide your I variable or the counter variable and initialization with a number, which can be 0 or any number you choose. Sometimes you may choose 0 or sometimes you may even choose 1 based on your requirement. Once the initialization part is done, we have I is equals to or less than a specific number, which is the condition. So that's where the control will check for the condition. In case if the condition is true, then the statement which is present inside the for loop will be executed. Once the statement is executed, then the last part, which is I++ or I-, which are your increment and decrement operators specifically. So those particular statements will be executed. In case if the condition is false, then the control will directly exit the for loop and execute the next statement which are lying after the for loop. So this is how the for loop works. For a better understanding, let's execute a practical program. So on my screen, you can see a simple program based on for loop. So what we have is an initialization variable I, conditional statement that is I should be less than or equal to 10, and finally a pre-increment operation which is ++I. So what basically happens here is it will print a print statement that is looped along with the I variable, which is 1 to 10 times. That's all. Now let's try to quickly run this program. So the counter variable that we provided is 10. So it has looped for 1 to 10 times. Now we shall also consider another example based on for loop. So now you can see another program on my screen. So here what happens is you get to enter a number. Now once you have entered the number will be evaluated as even or odd, and after that we will print the sum of the even numbers until the provided input, and followed by that the sum of the odd numbers which are present in between that particular segment. If you provide the number as 10, then the sum of the even numbers between 1 to 10 will be printed, and also the sum of the odd numbers between the number 1 to 10 will also be displayed. Now let's quickly execute this program and see the output. Now we have the program successfully executed, and on the output console you can see the console is asking us for an input. Now let's provide the number 10. Now there you go, you can see the even number summation from 1 to 10 is 30, and the sum of the odd numbers up to 10 is 25. So followed by the normal for loop, we have another for loop which is an advanced for loop. Let's check out an example to understand advanced for loop in a better way. So it is also called as enhanced for loop. Basically, the functionality of the enhanced for loop or the advanced for loop is completely similar to the normal for loop, but the only difference is it reduces the number of lines used in the code segment. Now let's try to execute this program and see the output. So basically we had an array which stored the string values, which are the names of the fruits, and using the advanced for loop statement here, we are going to access the elements inside the array and we are going to just print it. So that's what happened on the output console here. We have accessed the array, and inside the array we had the names of the fruits which are printed directly over here. Now with that, we will enter into the next part of our tutorial today, which is the while loop. So you can see on the right side we have the control flow for the while loop. So Basically, the control of the program enters into the while condition first of all, and it will check the condition. In case if the condition is true, then the statement inside the while loop will be executed and the control will get back to while condition for evaluation. In case if the control finds out the condition is false, then it will exit the while condition and execute the next particular statement. Now for a better understanding, let's execute a practical program. Now you can see that we have a program on my screen. So this particular program is really simple. All you get to do is enter an input, and that particular input number will be evaluated as a prime number or not a prime number. Now let's quickly execute this particular program. And there you go. The program has been successfully executed, and on the console it is asking for an input. Now let's enter a prime number, which is 7. So you can see the program has returned us that 7 is a prime number. Now we will enter into the next type of loop in our tutorial, which is the do while loop. So the do while loop and while loop are completely same to each other. There is no much of a difference. The only major difference between the both is the statement. In do while loop, first the statement will get executed. After the statement is executed, then the condition is checked. In while loop, we had the condition first. So the only difference is in do while loop, the statement will be executed at least for once without checking the condition. Now to understand do while loop in a better way, let's try to execute a practical program. So you can see that we have a simple program to execute the do while loop. All we have is the integer type variable I, which stores the value 1. And after that, we have the do while loop segment. So inside the do while loop segment, we have a print statement. So this particular print statement will print the value of I. And after that, the I value will be incremented. So this particular code segment will be executed before checking the condition, which is while I is less than or equal to 20. Once the statement is executed, the condition is checked. So let's try to execute this program and see the output. So there you go, the do while loop has been successfully executed and the numbers from 1 to 20 have been printed successfully. So this is how the do while loop works. Now with that, we have finished our introduction to Java programming language and also some of the basic concepts in Java programming language. So now we will enter into the next stage in Java, that is the object-oriented programming concepts in Java. So let's have a quick peek on the list of concepts that we will be discussing in Java object-oriented programming concepts. So first we will understand what exactly is a class and then the objects in Java. Followed by that, we will have a briefing about constructors in Java. Next, we will start with the core concepts of object-oriented programming, which are the abstraction, interface, encapsulation, inheritance, and polymorphism. Now, without further ado, let's quickly get started with classes and objects in Java. So what exactly is a class? Let's consider a small example. Assume that you're going to build a house. So before you build a house, you will create a blueprint. So with a blueprint, you can create any number of similar kind of houses. So similarly, in case of Java, a class acts as a blueprint. So class here describes the way or behavior of a particular object of its type. So followed by class, now we will enter into the next one, which is the object. So what exactly is an object? As discussed before in the normal example, the blueprint before building a house is considered as a class. And the building what you construct using the blueprint is called as an object. Similarly, in Java, objects have states and behaviors, and an object is an instance of a class. Now we will go through the three basic fundamental steps which are used to create objects and classes in Java. So the first step is the declaration step. You need to provide a name for your variable with relevant data type. After that, the second step is the instantiation. The new keyword is used to create a new object. Remember, whenever you try to create a new object using the class name, you need to specify the keyword called new. And the last stage is the initialization. After using the keyword, a constructor is called by the JVM to create the object using the defined class. So with that, we enter into our next concept, that is the constructors in Java. So first, we will understand what exactly is a constructor in Java. So a constructor can be defined as a built-in method that is used to initialize objects using the class definition. The constructor is called when the object of the class is created. So the one and only major purpose of a constructor is to build objects using classes. Now followed by the constructors, we have our next concept. Now we will be discussing the abstraction in Java, which is the first object-oriented programming property in Java. So what exactly is abstraction in Java? We will begin with the definition. So abstract class is a template of methods and variables used in a program. Abstract classes cannot be instantiated directly. So to simplify the definition of abstraction, we can consider abstraction as a process of hiding the complex code implementation from the user. So basically, it is a method of providing the user with the basic necessities what exactly the user is looking for by keeping him away from the complex implementations of the code. For example, if you're using Facebook, then you will be interested in messages and new posts or something similar to that. But you will not be worried about the code implementation which has been under Facebook application. So that's the basic definition of abstraction. Now that we know the basic definition of an abstract class in Java and also know the procedure of abstraction, we shall now move ahead and understand the features of abstract classes in Java. So there are mainly 5 features that an abstract class in Java has to offer. They are, so the first feature is a template. Abstract classes basically offer a template kind of structure to all the applications and softwares designed using this particular abstraction method. So the next important feature is abstract classes provide loose coupling. So what exactly is loose coupling? Loose coupling is a process where you keep the lowest possible dependency between a class and an object. So followed by loose coupling, we have the next major feature, that is code reusability. Using abstract classes, there is a high chance of reusing your code, which saves time and energy. The fourth feature is the process of abstraction itself. This keeps the user from complex implementations and only provides with the required information. And the last important feature is the dynamic code resolution. So now that we know the features of an abstract class, we will continue with an example for a better understanding of an abstract class in Java. So on my screen you can see a program. So this particular program is an example for abstract classes in Java. So to create an abstract class in Java, we are going to use the abstract keyword. So here I have created a generalized class which is a person. So this particular person will be having a name and a gender. So this particular abstract class will be implemented by another class which is called as an employee class. So this particular employee class will be having the employee ID, name of the employee and other details. So this particular employee will be extending the person class and it will be printing the details of a certain employee who is Pavitra Tripathi. Now let's try to execute this program and see the output. So you can see that the program got successfully executed and the particular employee, which is Pavitra Tripathi and her gender is female, is successfully logged into the office. Now with this, let us continue with the next topic, that is the interface in Java. So what exactly is an interface? So an interface can be defined as a container that stores the signatures of methods to be implemented in a code segment. To explain the interface in a much detailed way, an interface in Java programming language is an abstract type that is used to specify a behavior that a class must implement. They are similar to protocols. Interfaces are declared using the interface keyword and only contain method signature but not the complete method definition and constant declarations. Now that we know the definition and a briefing about interface, now let's get into the features offered by interface in Java. The first feature offered by interface in Java is the total abstraction. Next is multiple inheritance. So multiple inheritance in Java is not possible because it creates an ambiguity which is also popularly known as diamond problem. So by using interfaces, we can create an environment where we can implement the multiple inheritance. The last but not the least, loose coupling. Now that we know the features offered by an interface in Java, let's move ahead and understand the basic differences between an abstract class and an interface. So the following table describes the differences between an interface and an abstract class. So to declare an interface in Java, the keyword we use is interface. And similarly, on the other hand, the keyword used to declare an abstract class is abstract. The next difference between the both is subclasses can implement an interface, whereas in the abstract class, the subclasses extend the interface. So implement and extend are the two keywords. So if you had to borrow the properties of an interface into your class, then you need to specify it through the keyword which is implement. And similarly, in the abstract classes, you need to specify the keyword extends. So the third difference is multiple interfaces can be implemented. So just assume that you have multiple interfaces, for example, 3 interfaces. So if you wanted to implement all the 3 interfaces into one class, you can do that. But on the other hand, in abstract class, only one abstract class can be extended at one particular stage. And the final difference between the both is interface supports multiple inheritance. That is, it resolves the major issue related to diamond problem. And on the other hand, abstract classes cannot support multiple inheritance. Now to understand interface in a much better way, let's go through a practical example. So right now on my screen you can see a code segment. So this particular code segment is an interface. So here the interface name is area. So this particular interface acts as a container that stores the signatures of the methods. So the methods that we are going to use are square, circle, rectangle and triangle. So what does these methods do? They simply calculate the area of a square, area of a circle, area of a rectangle and area of a triangle respectively. So an interface just stores the signature of these 4 methods. So the implementation of all these 4 methods is inside this particular class, which is known as shape area. So shape area will be implementing the interface area. So inside this class we have the code implementation, which is dedicated to calculate the area of that particular shape. Now let's quickly execute the program and see the output. So there you go, the program got successfully executed and you can see the output displayed on my console right now. It's asking for an input, that is the radius for the circle. Let's provide the radius. So the radius provided was 15 and the area of circle with radius 15 is 706. So similarly, now it's asking for the length of the side of a square. So we all know that the area of a square is side into side. So 25 into 25 is 625. Now it's asking for the length of a rectangle. So similarly, let's also provide the breadth of the rectangle. So the area of a rectangle is L into B, which is 600. Now next we have the triangle. Now it's asking to input the base of the triangle. Next we have the height of the triangle. So the area of the triangle with base 35 and height 45 is 787. Now with this, let's enter into the next object-oriented programming concept, that is the encapsulation. So what exactly is encapsulation? So encapsulation in Java can be defined as a process of encapsulating or bundling the data and methods that operate on that particular data. So in simple terms, you're trying to combine the data members in a class or an object along with the data manipulating methods of the class or an object. Now to understand encapsulation in a much better way, let's try to execute a small program. So on my screen you can see a program. So in this particular program, the class name is encapsulation. So inside this class we have the name, ID and age of a person. So in the next segment of code we have another class called run. And here we are trying to encapsulate the methods setName, setAge and ID number of a specific candidate whose name is Harry, age is 25 and ID number is 829468. Now let's try to execute this particular code segment and see the output. As you can see, the code has got successfully executed and output is being displayed on the output console. Now with this, we will enter into our next concept, that is inheritance. So what exactly is inheritance? Inheritance is an act through which a new class gets created by acquiring the variables and methods which are defined in the previous or the parent class. For an example, consider an older model of a cell phone. So an older model of a cell phone had two major functions, which is call function and SMS function. Now imagine that you wanted to create a new smartphone, which has some additional functions apart from call and SMS, which might be media and internet browsing. Now let's come back to both the phones. Imagine that you have started to work with the creation of a new smartphone. So you had to define media, call, SMS and browse methods. But remember, in the older phone we already have the methods which are call and SMS. So will you create the call and SMS methods again, or will you use the code which is already defined for you? So the smart move would be using the previously defined methods into your new phone and only work on the two new methods, which is social media method and internet browsing method. So this particular approach or this particular process is called as inheritance. So basically what you're doing is you're trying to inherit the previously defined methods that are call and SMS methods into your new smartphone and adding the only necessary code for your smartphone, which will be the social media methods and internet browsing methods. So this is how inheritance practically works. Now there are four different types of inheritances available in Java. So the first one is single inheritance. In single inheritance, we have two classes. So here the class A is called as the base class or also a parent class. So the class which is inheriting the properties of a parent class or a base class is called as the child class. So in here, the B class is known as the child class. Now the next type of inheritance is the multi-level inheritance. So it is completely similar to single inheritance, but the only difference is we have another child, that is C. And here the one major point that you need to keep in your mind is the class B is also a child as well as a parent. So class B is a child to the parent class A, and class B also acts as a parent for the child class C. So here child class C is inheriting the properties from the base class A as well as its base class B. So followed by multi-level inheritance, we have the third type of inheritance, which is the hierarchical inheritance. So hierarchical inheritance has multiple child classes. So A is the parent class or base class, and the properties of A are being distributed amongst the child classes, which is B, C and D. And finally, we have the last type of inheritance, which is the hybrid inheritance. The hybrid inheritance name is self-explanatory. It is a combination of all the three inheritances. So here you can see the inheritance between A and BC classes is hierarchical inheritance, and the inheritance between C, D classes is single level inheritance, and the inheritance between classes A, C and D is multi-level inheritance. So to sum up, we can say the hybrid inheritance is a combination of any of the three inheritances. Don't worry, we will discuss each and every type of inheritance in a much more detailed way along with a practical example. So the first one, that is the single inheritance. Single inheritance consists of one parent class and one child class. Here, child class inherits parent class methods and data members. So to understand single inheritance in a much better way, let's try to execute a practical program. So on my screen, you can see an example based on inheritance. So here we have two different classes, that is student class and Bob class. Student class is the parent class and Bob is the child class. So what we are going to do here is we are going to extend the properties of parent class, that is student class, into the child class Bob. Now let's try to execute the program and see the output. So you can see that the program got successfully executed and we have extended the properties of student class into the child class Bob. Now with this, let's move into the next type of inheritance, that is the multi-level inheritance. So multi-level inheritance is also a parent-child inheritance relation, but the difference is the child class is inherited by another child class. Now let us consider an example based on sports bikes. So we have a program based on multi-level inheritance on my screen. So bike is the base class, and followed by that Ninja, which is the name of the bike, is a child class. And followed by Ninja, we have Ninja 1000R, which is one of the models of the name Ninja. So this is the last child class, and Ninja is a child class which also acts as a parent class for Ninja 1000R. Now let's try to execute this program and see the output. So the basic functionality of this particular program is to categorize the bike. So the category of the bike comes under 1000cc segment, and the make of the bike is the Ninja, and the model of the Ninja is 1000RR. The type of bike is sports, manufacturer is Kawasaki, and the maximum speed is 280 km per hour. Now with this, let's move into the next type of inheritance, that is the hierarchical inheritance. So the hierarchical inheritance is a parent-child relationship. The only difference is the multiple child classes inherit one single parent class. Now let's consider an example based on temporary employee and a permanent employee. So on my screen we have an example based on hierarchical inheritance. So in this particular example we will be considering two different types of employees. The first one is the permanent employee and the second one is the temporary employee. So both these employees will have to access one single parent class, that is the employee class. Now let's try to execute this program and see the output. So after executing the program, we have the output on the output console. So basically both the employees will access the same parent class, which is the employee class, which has the same number of leaves provided to both permanent employee and temporary employee. But there is a variation in the number of hours working. For a permanent employee, the total number of hours working are 8, and for a temporary employee, the total number of working hours are 10.5. Now with this, let's move into the next type of inheritance, that is the hybrid inheritance. As discussed before, the name is self-explanatory. Hybrid inheritance is a combination of any of the three types of inheritances supported in Java. Now let us try to consider an example based on hybrid inheritance, which will have the combination of single level inheritance, multi-level inheritance, as well as hierarchical inheritance. So here we have the parent class, that is C as a parent class, and A, which is acting as the child class, that is extending C. B will be extending C again, and D will be extending A. So as for the pattern here, we have B extending A and C extending A, and similarly D will be extending C and A. Now let's try to execute the program and see the output. So there you go. The program got successfully executed and the program has printed the output, which will explain the type of relationship of each and every class with the other class. So C is the parent class to all A, B and D. A has single inheritance with C and shares hierarchy with B. B has single inheritance with C and shares hierarchy with A. And finally, D has single inheritance with A and multiple level inheritance with C. Now let's continue with the next type of inheritance, which is basically not possible in Java, that is the multiple inheritance. In other words, it's also called as the diamond problem. In Java, we do not have the support for multiple inheritance as it ends up as a serious ambiguity. To resolve this issue, we have interfaces. Now, the next topic is the has a relationship and is a relationship. When a class inherits methods and members from a different class, then the relation is said to be an is a relationship. For example, orange is a fruit. Similarly, the has a relationship. When a class inherits the instance from a different class or an instance of its own class, then it is said to have a has a relationship. For example, orange has citrus taste. Now let's try to execute programs based on is a relationship and has a relationship for a better understanding. So as you can see on my screen, we have a program based on is a relationship. So we have the first class, which is the customer, and the second class, which is a bank. So a customer is related to bank. A customer is a customer with a specific bank. So what exactly we are trying to do here is we are trying to access the methods and data members from one class to another class. So we're basically accessing the methods of customer class through bank class. Now let's try to execute this particular program and see the output. So as you can see, the program got successfully executed and we have the information of the customers related to the bank. So we have 5 different customers, which are Raju, Shiva, Sachin, Prashant and John. Along with that, we also have their cities. Now with this, let us also try to execute an example based on has a relationship. So as you can see on my screen, we have an example based on has a relationship. So we have the first class, that is the school, which happens to be the parent class, and student happens to be the child class. So here we are trying to access the instance of the parent class. Instead of the data members and the data manipulation methods, we are trying to use the instance. So this makes this to have a has a relationship with another class. Now let's try to execute this particular program and see the output. As you can see, the program got successfully executed and we have the output which says Toby Marshall is the next student of St. John's School. Now with that, we have finished the inheritance in Java. The last topic for object-oriented programming is the polymorphism in Java. So what exactly we are going to discuss in polymorphism in Java? So the first one will be the types of polymorphism available in Java, which are the runtime polymorphism and compile time polymorphism. And next we have the super keyword. And finally, we are going to compare the differences between runtime polymorphism and compile time polymorphism. So first, let's start with the definition. So what exactly is polymorphism? So polymorphism is the ability of an object in a class to perform a task in multiple methods, which is known as polymorphism in Java. So polymorphism is basically divided into 2 categories. The first one is the runtime polymorphism and the second one is the compile time polymorphism. So what is runtime polymorphism? Runtime polymorphism is handled during the program execution stage. Here, the overriding method gets resolved in the execution stage. To understand runtime polymorphism in a much better way, we need to execute a program based on method overloading. So this particular code segment on my screen is an example for method overloading. So what exactly is method overloading? So method overloading is a process of having multiple methods in a program based on the same name. So you can see that I have a method with name add here, as well as another add method here and another method here. So what's the difference between all these 3 methods? So the first one is having integer type data variables or data members. The second one has double type of data members and the number of data members here are different, which is 4. And the last one has 2 data members but the data type is different, which is double. So when you pass the parameters of integer data type with 2 data members, then the first add method will be overloaded. When you send 4 different data members of double data type, then the second method will be overloaded. If you send 2 data members of double type, then the third method will be overloaded. So this is how the program works. Now let's try to quickly run this program and see the output. As you can see, the program got successfully executed and the outputs have been displayed here. Now with this, let's move into the next topic, that is the compile time polymorphism. So what exactly is compile time polymorphism? Compile time polymorphism is executed during the compilation stage. Here, the overloading method gets resolved in the compilation stage, whereas in the runtime polymorphism, the overloading method gets resolved during the run stage. Now to understand compile time polymorphism in a much better way, let's try to execute an example based on method overriding. So this particular example on my screen is based on method overriding. So both the civilian pilot and the cargo pilot will have to take off. So the output will be based on the method which gets overridden during the compile time. As you can see, I have stopped the civilian pilot over here using the quotes. Now during the compilation stage, the JVM finds that there is clearance for cargo pilot. So this method will be resolved during the compilation stage and the output will be cargo pilot ready to take off. Now let's try to execute this code. There you go. The program got successfully executed and this is the cargo pilot ready to take off. So this is how method overriding works in real time. Now let's move into the next topic where we will discuss the differences between runtime polymorphism and compile time polymorphism. So the first difference between the both is in compile time polymorphism, method call is handled by the compiler during compilation stage. While on the other hand, method call cannot be handled by the compiler in execution stage in the runtime polymorphism. The second difference is compile time polymorphism is less flexible and it needs to handle all methods in compile time. Whereas on the other hand, runtime polymorphism exhibits higher flexibility as the method calls get handled at runtime. The execution period for compile time polymorphism is less, whereas on the other hand, the execution period for runtime polymorphism is really high. Integrating the write method call with the write method is done during the compilation time. On the other hand, integration of the write method call with the write method is done during the runtime. The last difference between the both is the compile time polymorphism occurs during method overloading and operator overloading, whereas on the other hand, the runtime polymorphism is occurred only during the method overriding. Now we will understand what is super keyword. So super is a predefined keyword in Java that is used to refer the immediate parent class object or method defined in the program. So to understand super keyword in a much better way, let's try to execute a sample program. So on my screen you can see a code segment. So in this particular code segment, we are using the super keyword to access the object or the data member sites which is present in the immediate parent class. Now let's try to execute this particular program and see the output. So there you go, the program got successfully executed and the output has been displayed on the output console. So this is how the super keyword works. It tries to refer to the objects of the immediate parent class. Now with this, let's continue with the next topic, that is the access modifiers in Java. So the next topic is access modifiers. So what exactly are access modifiers? So here goes the definition. Access modifiers in Java specify the accessibility of a variable or a method by a same or different class or different method. So Java has 4 different access modifiers. So basically what an access modifier does is it provides the accessibility. So every data member, every data manipulating method, object, class will have their own personalized accessibility through access modifiers. So we will understand more about access modifiers and the different types through the following. So first one we have is the default access modifier. So what's the importance of default access modifier and what does it do? So the accessibility of default access modifier will have the permittability within the package. So when you provide a data member or a data manipulating method, class, object without any specific access modifier such as public, private or protected, so then the JVM will provide that particular object, class or data manipulating method or data member with default access modifier. So objects with default access modifier are accessible from anywhere throughout the package. Now followed by the default access modifier, we have the next one, which is the public access modifier. So the public access modifier and the default access modifier provide the same level of accessibility. The only difference is in public access modifier, you specifically provide the keyword public, whereas in the default access modifier, we don't have any specific keyword for that. So the example is right here, public int add int x int y. So here we have the integer type method add. So we are providing that with the access modifier public, and inside that we have the parameters. Now to understand this in a much better way, let's quickly try to execute a program. So on my screen you can see an example for public access modifier. So when you see on the left side, we have two different packages. So the first package being Java Simplilearn, and the second package is Simplilearn Java. So I've jumbled the words just to make it different. So now we have a program in Java Simplilearn, which is the child program. So inside this particular program, we have a statement which says system.out.println, and inside that particular statement we have a method call, that is a.add 100 to 100. So we are sending parameters, and you can see we don't have the addition function anywhere inside this particular code segment. So that particular add function or add method is provided in the different package, that is Simplilearn Java, and inside that we have the summation.java program. So you can see that we have the add method written inside here. So through child class we are going to access this particular method. Now let's try to run this program and see the output. So there you go, the program got successfully executed, and the summation of both numbers 100 and 200 is 300, which is printed on the output console. So this is how the accessibility of the add method is open through public access modifier. Now let's continue with the next type of access modifier, which happens to be the private access modifier. The accessibility of a private variable or a private method is completely limited to a specific class, and that particular class or a variable or a method cannot be accessed anywhere outside the class. So for example, we have a small code line here which is private int value is equals to 5. So we are using the keyword private, and we are declaring a value of integer type, and we are storing an integer value 5 inside that. Now for a better understanding, let's try to execute a small program. Now you can see that I have a program on my screen right now, which is a small and really simple program. We have getter and setter methods here, along with the integer type variable which we have declared as private. Now we are going to access that particular variable x is equals to 5 through our main class here. Now let's try to quickly execute this program and see the output. So there you go, the program got successfully executed, and we have accessed the value of private variable integer x through getter and setter methods from our main method, and we have also printed the message, that is hello world. Here is the function call for that particular message. So with this, let's continue with the next type of access modifier, which is a protected access modifier. So the accessibility of a protected variable or a protected method is limited to a particular package. So we have discussed this package thing in the first type of access modifier, which is the public access modifier. So imagine that you have declared some method or variable inside the first package, which was the Java Simplilearn. And if you wanted to access that particular protected variable or method from the different package, that is Simplilearn Java, then it will not be possible. Now let's try to understand this through an example. So we have the first normal line of example over here, which says protected void print method. So here the print method is being protected through the protected access modifier keyword. Now to understand this in a much more detailed way, let's try to execute a small program. So you can see that we have a program on my screen right now. So we have two different classes, which is the parent class and the child class. So the parent class is declared inside the package Simplilearn Java, and the child class is declared in the package Java Simplilearn. And inside the parent class we have a method which is protected, and that particular method is just a print method. Inside that we have a printf statement which is hello world. So inside the child class we are going to call that particular protected method, that is print. So we are using the command import everything from Simplilearn Java package. Now if we execute this particular program, we shall print that particular message which is hello world. So there you go, the program got successfully executed and the printf statement has been printed here. Now with this, let's continue with our next topic, that is the methods in Java. So methods. Methods are also known as functions in other programming languages such as C and C++. So basically methods are code segments that are called for any number of times and that can execute a task by just passing values. So we are quite familiar with methods. There is no rocket science in this. We have already executed many examples based on methods. Now, followed by the methods, we have the next crucial concept in Java tutorial, that is the collections in Java. So the first one is the array. So Java collections are also known as data structures in other simplified terms. So the first Java collection that we are going to study about is the array. So array in Java is a resizable array that is an implementation of list interface that allows null elements as well. Now we have three different types of arrays normally. So the first one is a one-dimensional array. So you can see on my screen we have an example for one-dimensional array. So basically in one-dimensional array we just have one single row and the elements in the row can be accessed through the index numbers. Now to understand this in a much better way, let's try to execute a small code. So on my screen you can see an example for one-dimensional array. So we have one row for this. So the row has 0, 1, 2 indexes and we are going to store 10, 20, 30 inside our array and we are going to print it. Now let's try to execute this program and see the output. So there you go, the program got successfully executed. So we have printed the message one-dimensional array and the elements 10, 20, 30. Now let's continue with the next type of array, that is the two-dimensional array. So you can see that there is much difference between one-dimensional array and two-dimensional array. So basically we saw that we had one row in one-dimensional array, but here we have two different rows. It's possible that we can also have more than two rows in two-dimensional array. So it's basically a matrix which can be represented with rows and columns. So if you wanted to access any element in this particular two-dimensional array, then you had to specify the row index and the column index as a pair. Now to understand this in a much better way, let's go through a sample program. So you can see an example on my screen right now which is really simple, which has just two rows and two columns, and it's a 2x2 matrix, and the elements which we are going to store are 1, 2, 3 and 4. Now we are going to use two for loops, one for the row, one for the columns, and then we are going to print the elements in the two-dimensional array. Let's try to quickly run this program. So there you go, we have successfully executed the program and the output of 1, 2, 3 and 4 along with their addresses has been printed on the console here. So now we have the third type of array, which is a three-dimensional array. By looking at the image, you can make out that three-dimensional array is basically the combination of multiple two-dimensional arrays. So here the elements are stored in a 3D Rubik's format, and you can access the elements in a three-dimensional array by passing three vectors at the same time. So with this, let's continue with the next topic, that is the stack. So what exactly is a stack? So stack can be defined as a subclass of vector that implements last in first out. Stack defines the default constructor which creates an empty stack. Now let's understand more about stack. So you can see on my screen we have an image of a stack. So stack is basically an arrangement of elements which follows first in first out. So just imagine that this is a container. So when you pass an element to the stack, then the first element will be located at the location 0. Followed by that we have the first and second elements. So first element to enter the stack was at stack number 0. So this element which came in first into the stack is the last one to leave the stack. Or in the other way around, stack also follows this principle which says last in first out. So the element at stack 2 was the last element to enter the stack. So basically it will be the first element when the stack starts to get empty. So this is how stacks work. To understand in a much more detailed way, let's try to execute a program. So there you go, you can see a program on my screen which is based on stack functionality. So first we are going to push the elements into the stack. Then we are going to pop the elements. Using the peek function, we are going to check out some elements which is on top and which is on the last. And also we can find if an element is present in the stack or not. So we have the functions over here which is stack, push, pop, peek, search. So we are going to pass some elements such as element 5, element 10 for searching this stack. Now let's quickly execute this program and see the output. So there you go, the program got successfully executed and we have the following output. And remember that we have passed two different values to search in this stack, that is 5 and 10. So the elements 5 and 10 are not present in the stack. So it has returned the message saying element not found. So as you can see, we have pushed the elements using the for loop. So the elements from 0 to 4 will be pushed into the array because we have provided the condition I should be less than 5 but not equal to 5. So the element 5 was not pushed into the stack. So when we have given the element 5, it did not find the element 5 or neither 10. But if we give the elements such as 2 or something, then I think we can find it. Let's try to execute the program once again. So you can see that the element is found at position number 3. So that's how it works. Now with this, let's continue with the next type of data structure or the Java collection, which is the linked list. So what exactly is a linked list? So linked list class can be defined as an implementation of a list and dequeue interfaces. This allows null elements as well. Now we have three different types of linked lists in Java, which are singly linked list, doubly linked list, and circular linked list. So you can see we have the first image which describes the functionality of singly linked list. So this part is called as the head, which is the starting part of the linked list. And this part is called as the tail, which is the ending part of the linked list. So in between the head and tail, we have nodes. So these nodes are the combination of the element value and the address of the next node. So the head will be pointing to the first node, which will have the first element along with the address of the next node. So this address block will point to the next node in the linked list. Similarly, the second element and the address of the third node. So this is how the linked list works. And at the end of the last node, instead of address value, we store a null value which indicates the end of the linked list. So this is how the singly linked list works. Now for a better understanding, let's try to execute a program. So on my screen you can see an example for singly linked list. So here we have defined the node which has the next value and the data. And inside the display function we are going to display the node head and the other data elements which are present in between the head node and tail node. And here we have described the head, second, third and fourth nodes respectively. And here we are going to display the list. Let's try to execute this program and see the output. So there you go. The program got successfully executed and we have inserted the nodes as 1, 2, 3, 4 and 1 is the head and 4th being the tail. So the list has been successfully printed here. Now with this, let's continue with the next type of linked list, that is the doubly linked list. So by looking at the image, you can make out that we can traverse doubly linked list in two directions. In the earlier linked list, we had one directional travel, that is from 1, 2 and 3 and done. But in doubly linked list, you can travel in two ways, that is 1, 2, 3, 3, 2, 1. So that's how doubly linked list works. That's the only difference between singly linked list and doubly linked list. So in the head part, you store the element value and starting address will be null, which indicates the first element of first node. And in this next address block, we have the address of the second node. And in the second node, we have two address blocks. So the first address block will point to the previous node and the second address block will point to the next node. So in the tail part also we have two addresses. So the first address will be pointing to the second, that is the previous element, and the last address will store null, which indicates the end of the doubly linked list. So for a better understanding, let's try to execute a program real quick. Now you can see on my screen there's a program based on doubly linked list. So similar to the previous example, we are going to define the node first. Then we are going to insert the elements into the doubly linked list, which are 1, 2, 3, 4 and 5. Then we'll display the list. So let's try to quickly execute this program. So there you go, the program got successfully executed and the nodes of the doubly linked list are 1, 2, 3, 4 and 5. Now let's continue with the last type of linked list, that is a circular linked list. By just looking at the image, you can make out that circular linked list is basically a singly linked list. The only difference is at the end point, instead of a null value, we have head value. So this head value will make the linked list to point out to the first element. So this makes it as a circular traversing linked list. So the name, circular linked list. So to understand circular linked list in a much more better way, let's try to quickly execute a sample program. So you can see that we have a program on my screen which is based on circular linked list. So similar to single linked list, we have the program here, but we are making a little change here, which is pointing the tail next to head. So that's the only difference that we have made in this program. Now we are adding the elements which are from 1 to 8, and at last we are going to display the circular linked list. So let's try to quickly execute this program. So there you see the program got successfully executed and the elements in the circular linked list are also printed here. So with this, let's continue with the next type of data structure or Java collection, that is the queue. So what exactly is a queue? So queue interface is from java.util package. It implements collection interface. The queue implements first in, first out. Remember, stack used to follow first in, last out, but queue follows opposite to it, that is first in, first out. So by looking at this image, you can make out that when an element enters into a queue, it locates at the queue location 0. So this particular element at queue location 0 will be the first element to leave the queue when you start to empty the queue. So to understand queues in a much more better way, let's try to quickly execute a program. So you can see that we have a program on my screen based on the queue terminology. So we are basically going to add the elements 4, 5, 3, 6, 8 into the queue. And you can also see that we have imported the libraries of linked list and queue together over here. And now we are also trying to remove some elements from the queue, and we are going to check for some elements in the queue, and also we are going to check out the size of the queue. Now let's try to execute this program and see the output. So there you go, the program got successfully executed. So as for the first operation, the elements 4, 5, 3, 6, 8 have been successfully added into the queue. So after that, we are going to remove an element, which is 4. So we have deleted that particular element. Now again we have the queue, which is the updated queue 5, 3, 6, 8, and the head of the queue is now 5. The size of the queue is 4. So this is how the queues work. Now with this, let's continue with the next type of Java collection. So that is hash set. So what is a hash set? So it is basically a hash set interface combined with hash map. It allows null elements as well. Now to understand hash set interface in a much better way, let's try to execute a program. So on my screen, you can see that we have an example based on hash set interface. We have imported the java.util.hashSet interface library. And inside this hash set, we're going to add elements which are the names of the bike makers. And we have also tried to include some duplicate values over here. You can see Yamaha has been included 2 times. And also we are trying to add null elements as well. Now let's quickly try to execute this program and see the output. So there you go. So hash sets does not allow duplication of elements, but they do allow null elements in the set. So that's how the hash set interface works. Now let's continue with the next type of data structure or the Java collection, that is the tree set. So the tree set is a navigable set implementation based on tree map. Here the elements are ordered using comparators. So you can see a program on my screen right now, which is an example for tree set. So we have imported the java.util.treeset library into the program. So inside the main program, we are going to insert some elements into the tree set, and then we are going to print the tree set. So let's try to run the program quickly. So there you go, the program got successfully executed, but there is a change in the order of printing. You can see the elements are already sorted from 0 to 8476, which is in ascending order. So sets basically arrange the order of elements by itself. That happens implicitly. So followed by tree set, another Java collection that we are going to discuss is the hash map. So hash map table is based on map interface. It provides map operations and allows null values as well. So to understand hash maps in a much better way, let's try to execute a program. So on my screen, you can see an example based on hash maps. So here we are putting the elements in the form of bikes. So Honda is the manufacturer and Shibuya is the bike name. Similarly, Kawasaki, Ducati and Yamaha. Now let's try to execute this program and see the way the hash map prints the data. So you can see that we have the elements here, Ducati, Panigale, and Yamaha R1. So basically maps follow the pattern of key value pairs. So you can see we have declared the hash map in the form of key value pairs. So the key is a string type data and also the value is a string type data. So here the key is Honda and the value is CBR, which is the bike which is manufactured by Honda. Similarly, Kawasaki Ninja, Ducati Panigale and R1 for Yamaha. So you can also see that the same is been printed also in the output console. So this is how hash maps work. So with this, let's continue with the next type of Java collection. So that is the tree map. So what exactly is a tree map? So tree map is based on navigable map. It is sorted according to the natural ordering of its keys depending on the constructor being used. So to understand tree map class in a much better way, let's try to execute the program real quickly. So you can see we have a program on my screen which is based on tree map class. So we have included the libraries java.util.map.entry and we have also used the star symbol in the first place. In case if we missed out anything, this should include everything else. So inside the main method you can see that we have 4 different key value pairs. So the first type is integer and the second type is the string. So the first integer type could be the employee number or the ID number of the particular candidate, and the name of the candidate is the string type. Now let's try to execute this program and see the output. So you can see the program got successfully executed and the key value pairs have been printed on the output console. So with this, let's continue with the next topic in our tutorial, that is the file handling techniques. So file handling techniques can be defined as a procedure to manipulate data via the file system. It includes create, get, read and write operations. So we shall execute a program for each of the file handling techniques starting from create to write operations. So the first one will be to create a file. So on my screen you can see an example based on file creation method. So we are going to create a file by name java simplilearn.txt. If the file already exists, it should give us a exception which says file already exists. If not, it should create a file. Now let's create the file. So when you run the program, it should successfully create the file. Yes. So it's thrown the message that is the file is successfully created. So after the first file manipulation operation, that is to create a file, the next one is to write into a file. Now you can see a program on my screen which is based on writing operation onto the file. So the file that we are going to write on will be java simplilearn.txt. Now let's get back to the documents where the program has created the java simplilearn file. So there you go. When you navigate through my documents and Java Eclipse workspace, and inside that we have Simplilearn Java package, and inside that we have the file Java Simplilearn. So basically this is empty now, it's just created right now. Now we are going to execute a write operation. Now we will be writing the following text into that file, which is files in Java might be tricky, but it's fun enough. Now let's try to execute this program and see the output. So there you go, the program got successfully executed and we have also included a print statement in this program. So even we have printed this particular text, that is hello, welcome to Simplilearn. Now let's get back to our file system and see if the data has been written into the file or not. So there you go, inside the Java Simplilearn we have got the text return, which is files in Java might be tricky, but it's fun enough. Now the last file manipulation operation will be to read the file. Now let's execute a program based on that operation and see the output. So on my screen you can see that we have a program based on reading function. So we are going to read the data which is present in java simplilearn.txt. Now let's try to quickly execute this program and see the output. So there you go. We have the output successfully executed and the statement which is present in the Simplilearn or java simplilearn.txt file was the same, which is files in Java might be tricky, but it is fun enough. So with this we have come to an end of this particular Java tutorial for beginners part 1. So if you had any queries regarding this tutorial or if you require the code that we have executed in this particular tutorial, then please feel free to write us down in the comment section below and we will respond to you at the earliest. Until next time, thank you.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.